So example 6.6.3, so finding probabilities for sample proportions. So it's believed that a candidate has 60% of the vote. They take a random sample of 100 voters, is asked who will they vote for, and the percentage that will vote for this particular candidate is computed. Okay, so again, this initial 60% that they gave us here is the value of P. They took a random sample of 100 voters, which is N. So we're asked again to identify the individual variable random variable x and random variable p hat in the context of the problem, and then we're asked to also list the given info with the correct symbols. So again, an individual is one of something, so one thing from the study is a voter. So again, they took a random sample of 100 voters. We take one of those as our individual. So this is a randomly selected voter. And each voter, we asked whether or not they were going to vote for the candidate. So whether or not they voted for this candidate. So again, this is a qualitative variable. So the random variable, so again, remember random variables are always numbers. So the random variable, since we have qualitative data, can either count how many of the voters voted for the candidate, or it can measure the percentage who did. So that gives us our two choices for random variables. So the random variable x is going to be the number of 100 randomly selected voters who voted for the candidate. And p hat is going to be the percentage of 100 randomly selected voters who voted for the candidate. So that's our only difference here, whether we count how many or measure the percentage. And then the givens that we had in the paragraph, we had p was 0.6 and little n was 100. So once again, we're asked what the distribution of the sampling distributions of the proportion is. And so again, to check to see if that's approximately normal, we have some conditions to check. So we're going to check that NP and N1 minus P are both at least 10. So little n is 100 times 0.60, and we want to know if that's at least 10. So that gives us 60 is greater than or equal to 10, which is true. And then n times 1 minus p, we get 100 times 1 minus 0.6, and we need that also to be at least 10. So if we compute that, we get 40. And that is also greater than or equal to 10. So that condition checks out. Again, this problem, no cap n is given. So we just assume the second condition is true. Again, we don't always just make assumptions, but when cap n is not given, it's usually because the population is so large. So again, cap n being at least 20 times little n is a reasonable assumption to make. All right, so since all the conditions check out, the sampling distribution of the proportion is approximately normal. And our parameters would be mu sub p hat would be equal to p, which in this case is 0.6. And sigma sub p hat is equal to p 1 minus p over n, the square root of all of that. So in this case, we get 0.6 times 1 minus 0.6 divided by 100. And again, the square root of that entire quantity. So part C says if you picked a random sample of 100 and you found 55% voted for this candidate, so lower than what you expected because you think you've got 60% of the vote, would that be an unusually low percentage of votes? And based on that, should the candidate be worried that they're losing popularity? So to determine if a value of a random variable is unusually low, we need to compute the probability of getting that value or smaller. And then we're going to see if that probability is less than or equal to 0.05. So again, for an event to be unusual, we need the probability to be less than or equal to 0.05. We're checking to see if the random variable is unusually low, so we're checking the probability of getting a value of that random variable in the lower tail. Alright, so again, p-hat values can only range between 0 and 1, but the mathematical model that we use to approximate those percentages runs from negative infinity, which we use negative 10 to the 99th power, to infinity, which we're going to use 10 to the 99th power. Okay, so for this particular interval that we've shaded over, it runs from negative 10 to the 99th to 0.55. So we're going to compute the probability of getting a p-hat less than or equal to 0.55. We check the conditions to know that the distribution of p-hat is approximately normal, so we can use normal CDF to compute the probability. And the left endpoint is negative 10 to the 99. The right endpoint is 0.55. And then the mean from up above was 0.6, and the standard deviation was 0.6 times 1 minus 0.6 over 100, and again, the square root of that entire quantity. So again, you should pause the video and make sure that when you type this in on normal CDF that you get the same output I'm going to write here. Okay, so if we do that, the output here should come out to be 0.15371708. Okay, so again, that corresponds to this shaded region. So the area of the shaded region is about 0.1537. So again, if we interpret this probability in the context of the problem, that tells us that there is about a 15.37% chance of getting a sample of 100 voters where at most 55% voted for the candidate. All right, this is not less than or equal to 5%. Okay, so this probability is not less than or equal to 5%. Okay? So it would not be unusual to get a p-hat of 55% if p really is 60%. Okay, so if the population proportion of people who are going to vote for a candidate still really is 60%, it would not be all that unusual to go talk to a random sample of 100 voters and only have 55% of them say that they're going to vote for our candidate. Okay, so the candidate should not be worried. Okay, they might be anyway if they don't understand statistics, but based on the statistics, they should not be worried. So the candidate should not be worried that their percentage of votes in the population has declined. Again, we're taking sample results and we're drawing an inference here now back to the population. Okay, so again, we're heading into that whole idea of inferential statistics. So, maybe people really do hate the candidate, and that's why we're seeing this lower percentage. But again, we don't think so. Again, it's based on our numbers we've computed. It's not so unusual for this to happen. It's going to happen 15% of the time. So they shouldn't be worried that the percentage has changed in the population. We just think this is a random sample fluctuation that we're seeing in the sample results.